Let's get started. Nice. So today I am sitting down with a fifth-year mechanical engineering student, Joanne Cai. Say hi, Joanne.
Hi.
And a lot of people know you for your work outside of the classroom, which is why I was so excited to bring you here today because of all of your work in extracurriculars and your co-ops and basically just being in the space industry. So thank you so much for joining us today.
Yeah, thank you for having me. I guess Emmanuel and I actually went to high school together. So
Yeah.
it's like,
Day ones, not even
Yeah.
high school, even junior high together.
yeah, I guess so.
Yeah,
Since grade 7.
Yeah,
Yeah.
it's been a long time. Okay,
Yeah.
so let's go back in the past. What was
Mm-hmm.
the starting point for you in joining the space industry, like positioning yourself to be going into the space industry?
Yeah, I guess when I started engineering at the U of A, I didn't really have a specific discipline or industry I wanted to go into. I actually had friends that were in AlbertaSat. I didn't even really know what the group did, but I was like, oh, my friends are in it. It's good to get involved. So that's why I ended up joining. So I did kind of fall into it. I didn't really intend particularly
really?
go into the aerospace industry. But I think when I joined AlbertaSat and I realized that they were kind of working on something that's at the forefront of the space industry or a new priority for the aerospace industry, I realized it was kind of a good position to be in and like a good club to stay involved with.
Cool. And what does AlbertaSat do?
So AlbertaSat is a primarily undergraduate student group at the University of Alberta, and we actually build, design, test, and launch satellites.
That's so cool.
Yeah, and so we mainly do, for our satellites, we mainly do CubeSats, which are cube-shaped satellites. So basically, it's about the size of a Rubik's Cube, and that's like one module, and you can stack up as many modules as you want. And obviously, the benefit of having this modular design is that it's cheaper, it's more standardized, it's easier to just add on a module. We have a 1U camera, and so we have just like our 2U satellite, and then you just throw another 1U module onto it.
Right. So it's
so
like almost
yeah.
like Lego kind of thing.
Yeah,
You just
yeah.
build on top of it.
Yeah, but I think one, I guess, like misconception, and I definitely had this going into, is I was like, oh, CubeSats are for student groups, or CubeSats are like cheap, worse versions of real satellites.
Yeah.
But especially being in AlbertaSat the past few years, I've seen that the industry is definitely moving towards, if you've heard of like new space, it's like faster, cheaper, faster turnaround, more modular, all of that, more accessible.
Okay.
And that's as opposed to like the James Webb, where it takes like
Right.
billions of dollars and so many years and super specialized and has one purpose. CubeSats can be launched rapidly, they can be prototyped rapidly, which makes more sense for an industry that's changing so fast as the aerospace industry.
Right. So CubeSats kind of just reduce that barrier of entry into like the satellite realm, essentially.
Yeah, so they are really great for like students, stuff like that. But they're also beginning to be used quite heavily in industry actually, and in academia. For example, like there's a lot of NASA supported CubeSats. I think one just discovered, I forget if it's Apex or Serbi, but it discovered a new radiation belt. Like it's doing actual science.
Cool.
If you know the DART mission where they like hit an asteroid, have you heard of that one?
No, but that sounds
It's a very
crazy.
interesting one. You can see like the footage. It's crazy. But they basically tried to like hit an asteroid to slightly change its trajectory.
With a CubeSat.
Not with a CubeSat,
Okay.
with a larger satellite. But the
Okay.
two CubeSats flying around it that got the, I guess like the interaction on camera were actually two CubeSats. And so that was like a deep space mission. So it's definitely not limited to like, oh, CubeSats are for rookies, they're cheap, they don't do real science. Things are definitely changing. And that's what I realized very quickly when I joined AlbertaSat, and what caught my attention and made me realize it was really worthwhile investing in.
Okay, sweet. And how did your choice in mechanical engineering play a role in going into AlbertaSat and taking on the space industry?
Yeah, so I'm a fifth-year mechanical engineering student now. I actually joined AlbertaSat when I was in first year, so I didn't know what discipline I wanted to be in. But definitely for aerospace, it is like every role you have will be very multidisciplinary. For example, I've done a lot of thermal work, which is like, it's a lot of like you kind of exactly what you learn in class, doing these calculations
Yeah, like heat
on the
transfer, stuff
satellite
like that.
thermals,
Yeah.
heat transfer. But you also need to have really good system-wide knowledge. You need to have an understanding of all the limitations of each component, the thermal limitations of each component. I think while I've done a lot of directly mechanical work, for all of that, you need a pretty good system-wide understanding. And then I've also done some work that's like super not mechanical. So I interned at Rocket Lab, and I was in manufacturing engineering, which is more managerial. It's more so, and also more systems type engineering, instead of, specifically doing like a CAD design or like stress analysis or whatever a mechanical engineer might do. It's more so managing the production line, since at Rocket Lab they have the production line and the engineering office in one facility.
Cool.
So the engineers are managing the production line. So there's a lot of kind of that crossover, or like you end up doing things that you're like, oh, this isn't exactly what I'm learning in class. But I think that's the nature of engineering. You kind of like, engineering is to teach you how to think in a certain way, and not necessarily like you're going to make drawings for pipelines for the rest of your life, right?
You're going to throw a bunch of calculations on paper. And
it's not like one thing.
Yeah, that makes sense. Can you talk a little bit more about how AlbertaSat really helped you to get that internship?
Yeah, so as I said before, I think very quickly when I joined AlbertaSat, I realized it was very well aligned with industry. For example, our current CubeSat project, and then the past CubeSat projects as well, were in collaboration with the Canadian Space Agency. So we actually got a grant from the CSA, and we do design reviews for all the design phases with the CSA. And so it's really valuable to be getting feedback from Canadian Space Agency engineers on your design. And then not only that, but following their standards. So because I had my experience there, and I also had more of a project management and systems engineering experience in AlbertaSat, I had more insight into what the industry expects and what the standards are there. And so I think that really helps in interviews when you're able to speak to, what phases they work in or what standards they use or things like that, protocols that they follow.
Right. Okay. Now I'm going to get into something a little bit iffy, okay? Mm-hmm. It's a weird one. That might be a little bit counterintuitive to some students. What do you think about the opinion of employers looking more at extracurricular knowledge, like stuff that AlbertaSat, and prioritizing that over GPA? So having a bunch of students, looking at a bunch of students, let's say at Rocket Labs, would you be prioritizing students that have worked on AlbertaSat that might have not had higher GPAs, or would you be looking at the 4.0 students that might have just been straight up book smart and only in school?
Yeah, I think it's a balance, which is obviously like the really nice answer.
Yeah.
But I do think it is a balance. Like, I think there's a lot of students that, because of the way university is structured, or for example, like we did our first year online, I think that affected a lot of people's GPA. Because of that, they might have a lower GPA, but through extracurricular or work experience, they've proven to be very reliable and very competent as an engineer. And so in that case, like, I think it's unfortunate to discredit someone because of their GPA. But I do think, like I would say for myself, I've prioritized academics while still trying to balance everything else, because like at the end of the day, you're here to take your classes and to learn. And it's a very rare environment to be doing classes all day. Like once you graduate, you're never going to go back to that environment again where you're doing like 4 hours of lecture a day. So I think some people go into university very like doubtful, I guess, of the benefit that lectures and classes will give them. But I do think, like, again, as I said, very rare to be in an accelerated learning environment like this. So I would say try to take advantage of it. Try to have as best of a GPA as you can. But I will say, like, I think when I was interviewing for industry jobs, and looking kind of at my peers when I was in industry jobs, I think it does matter less and less these days what your GPA is, and more extracurricular experience. Like when I worked at Rocket Lab, every single student there was part of their rocketry team or their satellite team or their formula team, because employers know those teams exist. And so they kind of get a resume and they're like, I'm familiar with the standards that these teams might follow or what a member of these teams might be expected to do. And so they're like, oh, this person's reliable, this person's independent, right? Yeah. So it is a very strong indicator of someone being like a good fit.
Okay, cool. And I want to talk a little bit about like that kind of balance between being in school and the extracurriculars, right? Mm-hmm. So I remember in like second year university when we spent like a lot of time together, it seemed like you did AlbertaSat like 80% of the time, 90% of the time, and then the rest of it, like the 10%, was actually on school. So like, how did you even balance that? Like, cause it seemed like you were so committed to AlbertaSat, yet you were doing so well in school still. So like, how did you balance?
I think it definitely is a balance. And I think at that time I was still learning how to balance it. Cause I've definitely had those like, put off school for so long because it's so much more appealing to go work on AlbertaSat than to like study for a midterm and then, kind of like this reckoning when you're actually doing the midterm. So yeah, it definitely is a balance. But I will say, like, especially in second year, one thing I realized is that being in AlbertaSat actually motivated me so much to do better in school because I felt like I could actually see why my degree was useful, or like I would learn something and kind of understand how it might be applied. And so it was way more motivating than just like doing school every day, submitting homeworks and you get a grade back, but like it's meaningless to you in the long run because you have no frame of reference. Like if I do well on my heat transfer exam, what does that mean? Does that
How am
mean
I going to apply it?
Like will I be good at anything as an engineer, right? Whereas when I started to be more involved in AlbertaSat, I kind of got that connection like, it's important to understand heat transfer because when I don't, I can't do this certain task in AlbertaSat, or I can't understand this certain aspect of the satellite. So I think a lot of people are hesitant to do like internships or extracurricular work because they don't want it to impact their academics. But I think it definitely motivates you and, like I said, gives you that connection, kind of bridges the gap. But yeah, it is a balance. And like, I think when you look at other people and you're like, oh, how are they doing everything? Like, it definitely comes at a cost. For me, I ended up extending my degree, which I think like it depends on what you prioritize. But in my position, I felt like I could extend my degree. And so I do have a lighter course load. Like I have a pretty light course load right now, which has helped a lot. And so you got to do what you got to do to make things work for yourself, right? Yeah. And like I would 1,000 times rather have my extended degree and lighter course load than be like suffering through the 7 courses and doing bad at everything and being overwhelmed. So yeah, it's like a balance of what you prioritize, right?
And you're still in AlbertaSat right now, right?
Yeah.
Okay, sweet. So I want to talk a little bit about the CubeSat. What do you think is the future of the CubeSat, and what projects have you already done in the past with AlbertaSat? Like, what was the applications of those CubeSats? Yeah,
so I'll talk a bit first about what I've done for AlbertaSat. So when I first joined AlbertaSat, they were working on the XAlta2 CubeSat mission. So this was a 3U CubeSat. So as I said before, 3 of those modules. And then one of the modules was a wildfire imager. We actually, when we were launching this satellite, we helped 2 other universities build their satellites. So we were doing 3 at a time. They were all super similar, but that definitely was an interesting endeavor to do 3 at a time. And so those launched in 2023. It was really special. We all got to go to Cape Canaveral, which is in Florida, and see the rocket launch. Cool. They launched on a Falcon 9, which is interesting. Because AlbertaSat's previous satellite before that launched on an Atlas V. So it kind of shows the space industry shifted so much in only 5 years. But yeah, so that was wonderful. And then right after that, we got the grant to start our next CubeSat, which would be another 3U, and we're calling it XAlta3. And so similar to XAlta2, it has a 1U imager, but this time we're going to be imaging ice and snow because there's a kind of a special situation with this CubeSat. Our previous CubeSats were all launched from the International Space Station, which kind of just like goes all over Earth. It has like pretty good coverage all over Earth. You can like see it from Edmonton sometimes. Whereas XAlta3, we may be getting a launch where it goes specifically around the poles, and that's why we've switched from wildfire imaging to ice and snow imaging to kind of take advantage of the orbit that we'll be in. So that's called a polar or sun-synchronous orbit. Anyways, we're about halfway through the XAlta3 design and development, and so we're going to launch in mid-2026, which is really exciting.
Cool.
So yeah, that's kind of where we're at with that right now. So because we have a launch coming up in like a year and a half, we're going to start integrating and testing the satellite pretty soon. So we'll have like actual hardware coming in the past month and like upcoming months. And yeah, putting everything together, seeing everything work. We're kind of past the design stage, so that's really cool. So yeah, that's for AlbertaSat. For CubeSats in general, I think they're definitely becoming more and more common. There's so many graphs that are like CubeSats launched per year, and it's just like a huge spike after like 2021, 2020, 2019, that area, especially with university teams. We are part of a Canadian Space Agency project called CubeX, where they're actually funding, I think it's 8 other CubeSats. So it's a priority for the government, for the Canadian Space Agency. They have very similar programs with NASA and in the United States. This past summer, I actually worked on an international collaboration for a CubeSat. So it was kind of based out of the University of Colorado Boulder, which is in the States. And it's called AlbertaSat. So this was actually a 27U, which is like vastly larger than any of the CubeSats I've worked on. Yeah. And so it was a collaboration between Germany, a school in Germany, a school in India, and then University of Alberta and University of Colorado Boulder. So that was really cool. But yeah, like 27U is like pretty crazy. But it kind of is a testament to how the CubeSat, kind of the modular methodology or like perspective, or I guess approach, is beneficial, and especially for academic and research uses. So I think we'll definitely see a lot more of that. If you look at like upcoming NASA missions, so many of them are CubeSats. So I think it's definitely only getting bigger.
What was the orientation of the 27U?
It's like
it's like
an awkward size. I used to tell people it was the size of a laundry machine, but I think that's actually like a gross overestimate. It's like the size of like it's the size of like those small like Dremel 3D printers. Yeah, I can't think of any other things to draw comparisons to, but yeah, it's quite
I don't know
large.
if you're allowed to say this, but I'm gonna shoot my shot anyways. Do you know how much each of those missions cost? Because I don't want students to downplay just because of it being small, that it seems like an easy task.
Yeah.
But you guys have so many students working on this. So like, can you kind of go behind what is the resources that are required to make one of these missions happen?
Yeah, for InspireSat, like the 27U, I don't know the budget. But for Exalta 3, we received around $350,000 from the Canadian Space Agency. But the launch itself is quite expensive, and we get that through the Canadian Space Agency. So like, I don't know exactly how much, but it's like ballpark, like $500,000.
Right.
And then we also, the 350,000 is not enough. We do like a lot more. So I don't know. I would probably say like for the hardware and the development, about $500,000, and then for the launch another $500,000, and so like combined maybe $1 million for the total mission. Obviously, it varies a lot. Like it depends on how much you spend on, paying engineers, which like we don't because we're a volunteer team. How much you spend on buying like high-end hardware. Obviously, we're quite limited as students. Like there's like crazy expensive hardware out there. For example, the ADCS system, which is attitude determination and control. So basically it orients the satellite, which you can imagine is important for an imaging satellite. You can't be like spinning up all the time. You have to hold it steady and take images. ADCSs can be like $40,000 or they can be like $200,000. So there's definitely a huge range. It is very expensive. But also compared to like the James Webb, it's like actually like a drop in the ocean, right?
Yeah, right.
Yeah.
How much did the James Webb cost again?
I think remember. Like $8 billion. I don't know. That's just off the top of my head, but like grossly over budget. Yeah, a lot of money.
Do you think that they're just going to keep pouring more and more money into just developing more CubeSats, like just investing in this technology?
I think so. Like, I guess from the limited amount that I've seen, I think so because, as I said, like it's cheaper. Like the James Webb just like ballooned in budget and complexity, whereas a CubeSat, you have everything contained to each module, and that doesn't necessarily mean you can't do as good science or anything. Again, you can have like a 27U, so it's still a huge satellite or like a pretty big satellite. Sorry, I shouldn't say huge because there's like enormous ones, but like a relatively large satellite. But you're still fitting the CubeSat form factor, so you're still able to use like standard off-the-shelf components. You're still meeting a certain like tried and tested standard. So yeah, I think so.
Okay, cool. And lastly, what is your best advice for engineering students or just students in general that kind of want to join the space industry and just maybe join AlbertaSat or just go on to build out a career in the space industry?
Kind of like how I said before, it's very rare to be in an environment like university. Like I think when we leave, we'll like realize this was kind of the only time we would ever be in an environment like this. So I think definitely take advantage of that, like the accelerated learning, the opportunities you have as a student or as an intern. Because when you're like a full-time engineer, you're expected to do a certain amount of stuff, but when you're an intern, they want you to learn, right?
Yeah.
So definitely take advantage of all of that, and like it's such a privilege to be in university and like at a part of a research organization where you have opportunities to participate in research or student groups or things like that.
Yeah, to work with all these amazing people and stuff like that. Yeah.
Yeah, so I would say I think that's one big one. And then the other big one, I think, is the space industry, especially in Canada, is super small. So it's that kind of, it's like good and bad. I guess it's small, so it's like hard to get in, but it's small, so it's also easier to kind of make personal connections and get to know other people. There's lots of like aerospace events. I actually think this evening, there's a company called Wyvern, which is a satellite company based in Edmonton, and the founding board is actually all AlbertaSat alumni. Their lead mechanical engineer is actually, I think, doing a demo in the garage or in the ice incubator. So there's like things like that. There's just like so many events, stuff like that. And again, the space agency or the space industry in Canada is very small. So if you are attending events like that, if you put yourself out there, get involved in student groups, it actually goes a lot further than you think it would because you're competing with like 2 other people.
Right.
So yeah.
Okay, cool. Thank you so much, Joanne, for joining us again.
Yeah, thank you so much.
Nice.